Hey class, Mr. Husted here, back in Better Than Ever. We are talking about Chapter 2, Lesson 3 today, and we're going to learn how to apply deductive reasoning. If you remember back 2 lessons ago, we did inductive reasoning, and basically what that means is you made a conjecture based upon a pattern or something that you could visually see. So deductive reasoning is a little different. Deductive reasoning is when we use facts, definitions, accepted properties, and laws of logic to form a logical argument. So this is really, we're right on the steps of jumping right into proofs. Don't mind me. I'll try to remember what I'm talking about here. Okay, so this is right on the doorstep of proofs. We're going to jump into a few laws here today. These are called the laws of logic. Okay, laws of logic. So if we take a look here, and again, these are things that I would highlight, circle, whatever it is you want to do to try and make sure that you remember. We have the law of detachment and the law of syllogism. I don't really know if that's how it's pronounced. That's how I'm going to pronounce it, so I hope you don't mind it. All right, so the law of detachment. So if the hypothesis of a true conditional statement is true, then the conclusion is also true. And then the law of syllogism. It's kind of like the transitive property. If hypothesis P, then conclusion Q, hypothesis Q, conclusion R, and then you kind of cross out the ones they have in common, and then you kind of just say the hypothesis from the first one and the conclusion of the third one, or the second one, excuse me, to make your third statement. So we cross out what they have in common. Okay? So basically, let's take a look at example number 1. We're going to use the law of detachment here, which again, basically just states that if the hypothesis is true, then the conclusion must also be true. Okay, so for letter A, it simply states if two segments have the same length, then they are congruent. Okay, so here is our hypothesis. If two segments have the same length, they are congruent. We know that the segment BC is equal to segment XY, so that means they have the same length. So what we can draw from that is that we also know that BC is then also congruent to XY. Okay. Mary goes to the movies every Friday and Saturday night. Today is Friday. I mean, if she goes to the movies every Friday and every Saturday night, if we know today is Friday, then we know that Mary is going to the movies. So, nothing too earth-shattering here. Mary is going to the movies. Sorry, sometimes I can't write and talk at the same time. So, okay, nothing too earth-shattering. Kind of common sense here. If you know the first part is true, then we have to just know that the second part also has to be true. So if today is Friday and Mary goes to the movies every Friday and Saturday night, she's obviously going to be at the movies tonight. Okay? So that's the law of detachment. Now the law of syllogism, which we'll talk about a little bit more about. It's kind of like the transitive property. We're going to look to see what each statement has in common, kind of cross it off, and then we can get rid of it then. But let's take a look at example 2a. If Rick takes chemistry this year, then Jesse will be Rick's partner. So here is a hypothesis, and then here is a conclusion. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. She hopefully can kind of see what I did there. If Rick takes chemistry this year, easy for me to say, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So we see what we have in common. They're the red statements. We'll go ahead and cross those out. So then we'll just bring down the parts that we already know. So if, let's change color. Nobody wants red. So if Rick takes chemistry, he will get an A. Okay, so again, you're looking for what they have in common, and then you're taking that out and putting the hypothesis from the first one in with the conclusion of the second one. Again, I can't write and talk at the same time. Okay, So the lost syllogism, taking out that common part. Okay, so letter B, if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. So sometimes it's not always going to be the conclusion from the first one and the hypothesis from the second one. You're looking for what's in common. So in this case, it's the x squareds greater than 25. You don't have to waver from the fact that this says if and this says then. So then if I want to write my if-then statement there for the next one, it would just simply say if, just bring it on down, if x is greater than 5, then x squared is greater than 20. Again, crossing out that common part and bringing down what's left. Okay? Right, let's go ahead and take a look at example number 3. Example 3 is going to ask us to use both inductive and deductive reasoning. So inductive to build up a pattern, and then deductive reasoning to come up with a statement about that pattern. Okay, so what conclusion can you make about the product of an even integer and any other integer? So product, remember product means multiplication. So we're talking even integer and any other integer. So let's pick some even integers, so like 2, 4, 6, and 8. And then let's pick whatever integer we want to multiply by. Let's see, let's do 2 times 3, 4 times, let's just go right up the line, 4, 6 times 5, and 8 times 7. 2 times 3 is 6, 4 times 4 is 16, 6 times 5 is 30, and 8 times 7 is 56. So again, we multiply, we had an even integer times any other integer. You could have picked whatever numbers you wanted to as long as one of them was an even integer, but I wanted to mix in odd and even numbers so that you could see kind of what happens here. So what do we notice about our answers here? I'm not looking for anything too specific other than they're all even. Okay, so if we want to write a conclusion statement about that, if we multiply an even number, I got to be a little more specific, an even integer and any other integer. So I kind of just took what they gave me up here. Then my product is even. Maybe a little more wordy than it needs to be, but it gets to the point. We did what they asked us to up there. We made a pattern, used our inductive reasoning to find a reason behind that pattern, and used our deductive reasoning to write this statement. Okay, and the last one. Let's just see if we can tell the difference between what is inductive and what is deductive reasoning. So let's remember inductive, usually a pattern or something that goes along with it. Deductive is like a definition. Okay? So each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. So if we're observing Monica kick a ball and it goes up in the air each time, we are noticing a pattern. And therefore, when we notice a pattern, that is always going to be inductive reasoning, because we are basing our information, our conclusion, on a pattern. So based upon what she's done before, we assume that when she kicks the ball up in the air, it will come back to the ground. I hope so, unless she has some powerful leg that kicks it out of this world. Okay? And then let's read the last one there. All reptiles are cold-blooded. parrots are not cold-blooded. Sue's pet parrot is not a reptile. And obviously that is deductive because we are basing it upon the definition of cold-blooded. Reptiles are cold-blooded. The parrot is not cold-blooded, therefore the parrot is not a reptile. Okay, so hopefully you've kind of gotten a nice little introduction here to deductive reasoning and understanding how to use different definitions and things like that in order to create conclusions from things that we are reading or that we are working on. Definitely look over the law of detachment. Remember, that's where we just, if the first part's true, then the second part has to be true. And the law of syllogism is kind of the transitive property where we're looking for that common part to get rid of. Okay? All right, try to keep it short and sweet. If you have any questions, bring them with you to class, and we will see you then.